Okay, so a matrix operations. Now, this is not Keanu Reeves in the Matrix. It's, a little different, you know, matrix we're talking about here. Big two things we're going to worry about today is we're going to do addition and subtraction. Go. And before we give you like a specific one, let me kind of show you what it is and how this thing sets up. When they talk about a matrix in this case, it's just going to be a bunch of numbers in here, but they're actually kind of identified by like rows and columns. So matrix, whenever they talk about a matrix, they're going to use a capital letter like A in this case. When they talk about the numbers on the inside, they're going to use like a lowercase letter. So this is going to be, now it's not A11, it's A11. We'll talk about what that stuff is here in just a second. A12, A21, and like A22, something like that. Okay, and what those letters stand for, they usually they call those subscripts for this part of it. The very first number that's here, this tells you the row it's in, so this would be the third row. And then your second number, that's going to be the columns. So first number is your rows, second number is going to be your columns. Okay, if we do matrix B, and it may look totally different. It may look something like this. Because the big thing is when you're doing these, you've got to be able to figure out what size the matrix is. And when you talk about the size, it's the row by the columns. So this one's easy because you got two rows and two columns. So this would be a 2x2 size matrix. For this one, you only got one column, but you've got 1, 2, 3, 4 rows. So this would be a 4x1 matrix. Okay. So before we get to the addition and subtraction part, we got to make sure everybody again kind of understands what's going on. So when we talk about matrices, which is plural for matrix, the little subscript numbers, sometimes you'll see those. That's talking about basically its location. So again, the first number is your row, second number is your column. And anytime you talk about the size, you always talk about the size of a matrix. It's always the rows and the columns first. So it's going to be that same thing. Rows is always first, columns is always second. And maybe I'm a little bit weird for me, but when I see these, I think columns first. So I always have to go back and remind myself that I got to do my rows first and my columns second, because for me, I see columns easier than I see rows. And I don't know why that is, but that's just the way I look at it. So I always have to go back and remember if I'm doing columns is my last number, and then how many times I go side to side on my rows, that's going to be my first number. Okay, so that's just kind of, again, realizing what the sizes are and what the numbers are, and basically what everything means for this thing. Okay, so if you've got to add or subtract matrices, and again, matrices is just matrix plural. You either add or subtract numbers that are in the same location. And again, it's row column thing on it. But again, you can think top left, top right. Let's go to Richie. Okay. Wait, he's in the next block already. It is. Okay, no problem. Bye. Okay, which means if you're going to add or subtract two matrices, the matrices have to be the same size. If they give you one that's, if you go back up here, if you had got one where it's a 2x2 matrix like this one, and the other one's a 4x1 matrix, you cannot add these two things together because they're not the same size. So if you're going to try to add or subtract, they have to be the same size. If they give you two different size matrices and they ask you to add them, it's just, you should have an option that says not possible, because sometimes they're just not the correct size and there's nothing you can do with those. Okay, so what we're gonna do, let me give you two matrices, and we're gonna add them and subtract them just so you can see what it is. And again, it's not anything, it's not mind blowing. You're gonna look at it and go, yeah, that's what it is. So. Okay, so matrix A, negative 12, 24, negative 3, 5, negative 1, 10. And then matrix B is negative 3, 1, 2, negative 4, and then negative 1 and 5. Okay, and one thing they're not going to ask you to do, but we're just going to make sure we've got the size on this one. So if you have to do the size of these two, again, you've got two columns, but you've also got three rows. So again, if you go side to side, we've got basically that's three rows and then two columns. So basically our size, the matrices in this case, they're both 3x2s. All right, so again, if you're going to add them, it's pretty straightforward. You start in the left corner, top left corner. You're going to take negative 12. You're going to add it to the number that's in the same spot here. So it's just negative 12 plus negative 3. Then we're going to add 24 plus 1. Next row, first number in the next row, first number over here, so it's negative 3 plus 2. 5 plus negative 4. It's negative 1 plus negative 1, and then 10 plus 5. Okay, and from there, just do the math. It's negative 12 plus negative 3. That's negative 15. It's 24 plus 1, which is 25. Negative 3 plus 2 is negative 1. 5 plus negative 4 is 1. 1 plus negative 1 is negative 2. And then 10 plus 5 is 15. And some people may go, well, do we actually have to show this if we're just going to add these two things together? Not necessarily, no. You can, if you can do it in your head, if you can just do negative 12 plus negative 3 and go ahead and do that and write the answer out, that's fine. Just sometimes it's better to take that one extra step just to make sure you don't. Sometimes you mix some stuff up, so just take your time as you're going through those. Okay, so addition, pretty straightforward. Subtraction should be pretty much the same type thing. Now we're just going to subtract numbers instead of adding numbers. Somebody say go back. Okay. You're welcome. Everybody good? Okay, A minus B, exact same thing that we had here, but where we've got a plus in the middle, basically we're just going to need a minus in the middle. So it's negative 12 minus negative 3. It's 24 minus 1. It's negative 3 minus 2. It's 5 minus negative 4. It's negative 1 minus negative 1, and then it's 10 minus 5. Okay, so it's negative 12 minus negative makes that plus. So really it's negative 12 plus 3. So that would be negative 9. 24 minus 1 is pretty straightforward. It's just 23. Negative 3 minus 2 is negative 5. 5 minus negative 4 is really 5 plus 4, which would be 9. Negative 1 plus 1 would be 0. And then 10 minus 5 is 5. Okay, so again, subtraction, nothing really weird about it. It's pretty straightforward. It's just you have to be careful with your signs because with subtraction, you're going to have some minus negatives that you've really got to wind up making it into a positive, and then just kind of go from there. Okay, so addition, subtraction, it's just that straightforward. Just add the numbers, subtract the numbers, and then that's all you've got to do. Now, where they're going to ask you to go a little different route, but still doing the same thing, is they're going to ask you to solve a matrix. So just using some different ones for this one. Let's say matrix B is 1, 6, negative 1, 2, 6, 1, negative 1, negative 2, 4. So matrix C will go 2, 0, 0, negative 1, negative 3, 6, and then 2, 3, negative 1. Okay, so they may do something like this and say, okay, we've got matrix B and C. They may tell you to find A when A minus B equals C. Okay, and for that one, you have to think about it basically being like just a regular solving equation. If you've got to solve for A, if this was A minus, doesn't matter what it is, if it's A minus 2, you would do a plus 2, right? So for this one, same thing. We're just going to do a plus B on both sides to get A by itself. So A is going to equal C plus B. So to figure out what A is, we just got to take C and B and just add those two things together. Okay. And because it's addition, you may not actually have to write out all the steps on it. So for this part of it, we can probably just go ahead and do that. So for A in this case, we're just going to add B and C together. So that's 1 plus 2. So that's 3. It's 6 plus 0, which is 6. and it's -1 plus 0, which is -1. Okay. Again, with addition, you can probably just run through and not have to write out the steps in between. It's 2 plus -1, which is really just 2 minus 1, which is 1. It's 6 plus -3, which is really just 6 minus 3 for 3. 1 plus 6 is 7. And then we go to the last row on the bottom. It's -1 plus 2, or it's 2 minus 1 for 1. It's -2 plus 3, which is 3 minus 2, which is 1 again. And that's 4 plus -1, which is really 4 minus 1, which would be 3. But a matrix with all zeros. They call it a zero matrix because it's all zeros. And sometimes they may throw this out there too for this part of it. Sometimes they may also call this, or give you an AKA here, it's the identity matrix of addition. So, y'all remember when y'all did all the commutative property and associative property and all the multiplicative identity? It's that same kind of thing that if you added 0 to a number, you got the same number back. Well, same thing if it's a zero matrix. If it's a zero matrix and you add 0 to everything, you're going to get the same thing back. So they say, all right, well, this is just the identity matrix of addition, where it's like the identity property of addition. It's the same thing because you're adding 0. If you add 0, you're going to get the same thing back. So you're not going to change whatever it was. So that's the identity matrix part, is that you're going to get the exact same thing back as you go through those. Not a big deal, but sometimes that will pop up. If they throw that definition out there, just realize if they talk about the identity matrix of addition, just realize that's just a zero matrix. That's all it is when it goes through that part. Okay, and then the last thing we've got to deal with for this section is they're going to ask you to find some unknown values from one matrix or two matrices. Okay, so there's our problem we're looking at. Okay, so if you've got something like this and they're asking to solve the different values here, you're going to do kind of like the addition part. That for this part of it, though, you're just going to take whatever's in the top left corner that's here and then set that equal to whatever's in this corner here. So again, same location. So take the location in this corner or this matrix, set it equal to the location in this corner. And then once you do that, then you just solve whatever equation you've got there. So x plus 3 equals 9. So we'll subtract 3 from both sides. So we get x equals 6. Okay. And then just go to your next location. And some will have you do more work than others. This one, if you set -2 equal to z, well, there you go. The answer is already there because it's already done for you because, well, it's just z equals -2. Okay. And if you go to row 2, location 1, or column 1 on both of those, you've got the y's. So you've got y minus 1 equals 2y plus 5. Got to do a little more work with this one. We're going to subtract y from both sides. So we've got -1 equals y plus 5. And then we'll subtract 5 from both sides. So this one would be y equals -6. Okay, and then now the last corner that's here, it's got x values here. If that's the case, you don't have to set these two equal to each other because you should get the same answer here. So if you did do the x plus 1 equals 7, then you would see that you same thing. You would still get x equals 6. But again, you don't have to do that corner because you've already got that same value for x that's here. So sometimes they may give you more values in different locations. Once you've got the value for x, you don't have to go back and solve the other corner because, again, you already had the x value here, so you didn't really need this one here.